Last time we had a destroyed rocket, so we're gonna have to fix that. So in making a new rocket, I learned a lot from the first one and I had a ton of improvements to make. On the newer version, I ended up using a few new parts. Those include a new vectoring system inside the engine mount, and I ended up using a brand new flight computer. Big improvements I made here were new fins. These new fins are higher up on the airframe, so they have more control authority in the wind. This will be really helpful if I ever make it to the point of propulsive landing and I need to orient the rocket engine in the right direction. The fins spring out radially around the rocket and they reverse to prevent tumbling in any given direction. Finally, I did a few upgrades to the stage separation mechanism that allows the first and second stage of this rocket to separate. Now, I haven't forgotten that I need to do the second stage, but it is a lot of buildup and I don't want to have the same issues I've been having with this rocket and the previous one on a much more expensive and complicated and way more to go wrong two-stage rocket. With this rocket, I've had several flights already. None of them have gone well. But if we run through each of these, you're gonna see a common thing. In each flight, there is no vectoring going on. And it took me a while to understand why exactly this was happening. And it has been a huge pain. There is a software bug hidden in my rocket's flight software that has plagued things since the beginning. And Only after kind of taking myself back to dynamics class did I realize what I had done wrong and why things weren't working.
Hey, so welcome to Rob's Terrible Dynamics lesson. And today we're going to be talking about why things haven't been flying properly. So in physics, we draw a lot of these things called free body diagrams where it shows all the forces on an object. So in this case, this skier. Now this person is being slowed down as much as they're accelerating down the hill. So all the forces here are balanced. But what we care about and why things aren't working is when things are accelerating. So all of a sudden, we have a net acceleration that's way more than all the others, and we're going to be picking up speed in that direction. So for rockets, here's a basic diagram. If you've searched free body diagram by now, you've probably come up with this. And it basically shows the lift acting on the rocket because it is in the air, the drag because it's also in the air, and the thrust force pushing upwards up here. So here's a more complicated version. It includes a few extra things on the torque on the rocket and the thrust vectoring and all that stuff, but that's a little too complicated. So then why we care about all this is Newton's second law right here. So a force is just a mass times a change in velocity with time here. Or if you want it real simple, force is mass times acceleration. So if we know the mass of our rocket, which we do, we can figure out the force by looking at the acceleration on it. And you can do all sorts of fun control methods using that technique. But we want to go even more deep than that, because we're looking at the acceleration because that's what our sensor or our IMU on board says to us. So when the rocket's just sitting here on the ground, it's not going anywhere. It is at rest, and when something's at rest, you have to accelerate it. But it's already under acceleration, and that acceleration is gravity. So just sitting on the Earth, everything is being pulled downward with an acceleration of 9.81 meters per second squared. And if you ever remember anything in physics, it's that number. That's all you need to know, basically. But that 9.81 meters per second squared is pushing down towards the Earth. So, depending on how you define your coordinate system, changes things for you. We got this positive direction here, so we would assume that our sensor would read a negative 9.81 meters per second down and a positive whatever we're accelerating in the other direction. Well, let's look at things a little differently, because that is a little less intuitive than it might seem. At some point, you're going to have these balance out, and you're going to have a little bit of a net force here in this amount. And that force is going to accelerate this mass however fast it's going to go. And it's going to accelerate it this way. But the sensor, guess what? The sensor's feeling the force, so it feels it this way. And I know that sounds so backwards at first, because all of a sudden, if we're going up, we have negative 9.81 meters per second, and then we also now have, however fast we're going to accelerate on top of that, we don't know exactly how fast it could be, because we have to subtract out that 9.8 meters per second. So we're going to accelerate. This way, forward, but our sensor on board is experiencing it like a rider backwards. So all of a sudden, instead of having negative 9.8 pulling backwards, we could now have negative 15 meters per second squared, which that is not positive this way. And if our computer is programmed to detect a positive acceleration, i.e. assuming that we'll feel a positive acceleration going forward, then guess what? We're never going to get there because we're feeling it in reverse. This is really, really similar to whenever you've been in a fast car, roller coaster, anything that accelerates really fast. You'll feel yourself thrown back into the seat. That's your inertia pulling you backwards with an equivalent force to the acceleration. So it experiences the same acceleration, just backwards. So in my programming, I assume that at a greater acceleration than gravity here, we can activate the guidance loop on the rocket. So if we hit -7 meters per second, which is in my mind originally a small positive acceleration over gravity, then we've just barely left the ground, and then we can begin thrust vectoring. But in reality, it's not accelerating that way. Like I said, it's feeling the acceleration in reverse. So this will never be met because the actual acceleration is negative. It goes backwards and not forwards. So this would never happen. We'll never get to -7 meters per second squared because we're not accelerating that way to the sensor. Only if we were accelerating into the ground more, like in free fall, would we feel less acceleration, like going down the stairs. So this -15 meters per second acceleration means the conditional statement never trips. And if I had just ever so simply made things like this, then it would have tripped and the entire guidance system would have detected this changing acceleration as it's flying, and all the previous flights would have worked if only I had noticed this stupid sign error.
Ah! So after the first attempt, I got some rather pretty looking images of the launch, but I didn't get a good flight. And after attempting to review the data afterwards, I found there was no data. So one of the first issues I encountered with this new design, where it can log data during flight so that I can review it later and better understand what the vehicle's doing, was it wasn't starting up. It was a really weird issue where sometimes it would work, sometimes it wouldn't, and I would bench test everything over and over again and get success, take it out to the field, and I would have a failure of the rocket to start up. One of the other big improvements I've put on this new vehicle is a better safing and arming system. The new safing and arming system is pin-based, so you pull a pin and the whole vehicle can start up electronically, and then a second pin arms all the pyrotechnic initiators on the rocket. All of the pyros get safed by a single removable pin that blocks the connection to the 12-volt signal. On the other pin, it blocks the connection to the 12-volt positive that runs the entire computer. So pulling both pins is necessary before launch. One of the other big improvements I made was a new tail umbilical system. The old umbilical yanked on the side of the rocket, and this was kind of no good. It would nearly pull it over, so the new fix used 3 2mm bullet connectors that insert into the bottom of the rocket, and as it leaves the ground, it unplugs itself. This is pretty common, and it just moves my rocket a little closer to the actual real-world Antares launch pad, which has a strikingly similar system. So with a little more scrutiny, I came back into things and I looked at the sensor and why it wasn't detecting anything. And the closer I dug, the more I found there is an intuitive problem with the microcontroller board I chose and the sensor that I chose, where it'll work sometimes and not work others. I ended up talking to my friend Josh, who came up with a great little breakout board that swaps directly in place my old IMU and replaces it with a better one. So it's a pretty quick fix, and Josh really knocked it out of the park. The new sensor is actually a lot faster than the one I had before, so it's an upgrade overall, and I intend to use this sensor as opposed to the older one that I had been working with, just because it's more reliable and it starts up now every time without fail. I thought I had fixed my problem, I was in the clear, and I was really confident showing up at the launch site again. immediately things begin to careen off course, but this time, because the sensor worked, I was able to get good data. And that data led me to a flaw hiding inside my software since day one. So the amazing thing is, in all of the previous flights that I've ever had with this rocket, this code has always been there. 2 times it worked perfectly. I came to another realization, and that's that the 3 flights that I had successfully were flukes. In the liftoff process, the accelerations must have just barely worked out and triggered the guidance loop to start up, because in every other instance that I've tried to fly the rocket on this software, I ran into this issue where it tumbles end over end and it doesn't detect liftoff. And that all comes down to a faulty understanding of those relationships between the acceleration and how the acceleration is felt on board. They're basically 2 different reference frames, and they don't exactly align unless you have the knowledge behind them for how the physics works. With this information, I changed the software, and now I can double check things, and the rocket still arms when you accelerate it up, but it arms actually faster, because instead of being accelerated in my hand upward and then stopping, which imparts another negative acceleration, it triggers the guidance loop on the upward swing instead of the stop. And that is why I never caught it, because every time I physically accelerate the rocket, I have to stop it and I impart a negative acceleration. So after all this digging, I finally found the one issue that's been in there the entire time, and I think I finally knocked out all the really big software bugs in this code, and I will have something that flies properly.
Hey, this is Rob in the future, and I forgot to record an outro, so I just want to say thanks for watching, and we should have another launch here any day now. The weather has finally gotten a lot better.